Hi dear students, how you all? Hope all of you are fine. Now I am here to describe about limiting reactant from chapter 6 chemistry. What is the definition of limiting reactant? The limiting reactant or limiting agent is a reactant in a chemical reaction that is totally consumed when the reaction is completed. If the reaction is completed, then one reactant is totally consumed or run out. This reactant is called limiting reactant. Suppose you will prepare a pan. For this, you need one cap and one body of pan. Then you can get a complete pan. If you want to prepare two pans, at that case, you need two caps and two body. Then you can get two complete pan. But if you want to prepare three pans, at that case, three caps and three bodies are needed to prepare three pans. But if you take two caps to prepare three pans, it is not possible because you haven't taken three caps, you have taken only three body. At that case, limiting is cap. Cap is limiting element because you haven't take a proper amount of cap. It has been run out. If you take two body and three caps, at that case also you can get three pens. In this case, you will get two pens because you haven't taken proper amount of body. So at this case, pen body will be limiting element. Suppose you like coffee and at evening you drink coffee. For this, you will prepare coffee for you. So you need to take 1 spoon milk powder, 1 spoon sugar, 1 spoon coffee powder and 1 cup of water. Then you can get 1 cup of coffee. If you want to take another cup of coffee, that means 2 cup of coffee, then you need to take 2 spoon milk powder, 2 spoon sugar, 2 spoon coffee powder and 2 cups of water. Then you can get complete 2 cups of coffee. But if you take 1 spoon coffee for 2 cups of coffee you want to prepare, at that case it will not be possible because you haven't take proper amount of coffee powder. At this case, coffee is limiting element because it has been run out. If you think you will prepare 3 cups of coffee, at that case you will need to take milk powder 3 spoon, sugar 3 spoon, coffee powder 3 spoon and water 3 spoon. Then you will get 3 cups of coffee. But you haven't take 3 spoonful sugar. You have taken 2 spoonful sugar. In that case, you can't get proper 3 cups of coffee. You will get 2 cups of coffee because there is a scarcity of sugar. So at that case, sugar is limiting reactant. Consider another one. If you take 1 cup of water to prepare 2 cups of coffee, you need to take everything 2 spoonful milk powder, 2 spoonful sugar, 2 spoonful coffee powder and 2 cup of water. But if you take just 1 cup of water, it is not possible for you to prepare 2 cups of coffee. At that case, water is limiting reactant. So the element which will be run out first, it will be called as limiting reactant. If I tell hydrogen and oxygen, then water, then there are 2 atoms, will write here 2, so this. So hydrogen and oxygen, these two are called reactant and this is product. So here we know 16 into 2, that means 32 gram. Molecular mass of oxygen is 32, and here 2 into 1. Atomic mass of hydrogen is 1, and there are 2 atoms, so 2 ones are 2 and 2 equal to 4 gram. So look, there are 4 grams and there are 32 grams. So we have got here product. We can count total number of here in gram unit. 2 into water, 1 into 2 plus 16. That means here 2 into 18, that means 36 gram. So look, 4 gram and 32 gram, total 36 gram. That means if you take 4 gram hydrogen and 32 gram oxygen, you will get 36 gram water. But if you don't do this, like suppose 4 gram, 4 is to 32, that means 1 is to 8. You can, if you take 1 gram hydrogen and 8 gram oxygen, then you will get a product, suppose 9 gram, total 9 gram. So ratio will be 1 is to 8. But if you take suppose 440 gram, then you need to take here, then the reaction will be completed and you won't get any type of reactant left over. Any reactant will not be left because the ratio is okay. If you take 400 and here 3200 gram, that means 3.2 kg and this gram, then the product will be formed and the reactant will be consumed, both reactant. At that case, you can't get here any type of limiting reactant. All are used up. Both reactants are used up at that case. If you consider this, suppose here 2 mole and here 1 mole, that means 2 mole hydrogen and 1 mole oxygen. If you take here 8 mole, look, so you need to take here 4 mole. If you take 8 mole and 4 mole, then both will be used up and you can't get here any type of limiting reactant. Both will be used up. You will get just water. So limiting reactant will be this one that will be finished first or run out, and one will be left or one will be excess. Like this, suppose this is 4 gram and this is 32 gram. If you take here 2 gram and this is 32 gram, then what will be happened? Look, proper amount of hydrogen is not taken here. We know for 32 gram oxygen we need 4 gram hydrogen, but we have taken only 2 gram. That means this will be finished up because for 4 gram we need 32 gram. For 4 gram we need 32 gram oxygen, 4 gram hydrogen. So if I write for 2 gram, if I write 2 gram first 1, then 32 divided by 4, and if I write 2 gram, then it will be 32 into 2 divided by 4, then look, 8 equal to 16 gram. 16 gram. So if you take 2 gram hydrogen, you need 16 gram oxygen, but we have taken here 32 gram. So for 2 gram, if I take 16 gram, then it will be used up, but I have taken a 32 gram. That means see another 60 gram will be left over. Oxygen will be left over, oxygen will be excess, and hydrogen will be used up. So at that case, hydrogen is limiting reactant. Consider another reaction. Consider another reaction. This is calcium plus oxygen, then calcium oxide. Then two atoms are there, that's why I have written here 2. So 2 atoms are at the right side, so I'll write here 2. This is a balanced reaction. So what is the atomic mass of calcium? 2 into 40, so 80 gram. And what's the atomic mass of oxygen? 16 into 2, that means 32 gram. So if you take 80 gram calcium and 32 gram oxygen, then both reactant will be used up. Both reaction, no any reactant will be excess. Both will be used up, and there is no any limiting reactant. If you take here 800, just I have multiplied by 10, and here 320 gram, then both will be used up. No any excess amount of reactant will be found, and the product will be got. If you consider as a ratio 80 is to 32, that means 5 is to 2. That means if you take 5% calcium and 2% oxygen, then no any limiting reactant will be found and no excess amount of reactant will be found. That means total reactant will be produced as product. But if this ratio is not maintained, suppose you will take 150 gram calcium and 46 gram oxygen. 150 gram calcium and 46 gram oxygen. Then is there any limiting reactant, or is there any reactant that will be left over? We can calculate. Suppose if I take 80 gram calcium, we need 32 gram oxygen. So using this calculation or using this amount, we can find which one will be limiting reactant. That means which one will be consumed fast or which one will be run out fast. Suppose 80 gram calcium reacts with 32 gram oxygen, then 1 gram and 150 gram. 1 gram calcium 32 divided by 180 and 150 gram, then what it will be? It will be 32 into 150 divided by 80. So we can get here 32 into 150 divided by 80. So here we have got here 60. That means we have got here 60 gram. So if I take here 150 gram calcium, then we need 60 gram oxygen. But how much we have taken here? 46 gram. The required amount of oxygen is not taken here. 80 gram calcium, if I take 80 gram, we need 32 gram. I have calculated based on this amount that if I take here 150 gram, so I need this amount. Then we can get product and no any reactant will be left over and any limiting reactant will not be found. But if I take 150 gram calcium and 46 gram oxygen, then oxygen will be limiting. That means it will be used up. It will be run out fast. So this is limiting reactant. So if I take 150, okay, and if I change this, suppose 80 gram, look, if I take 80 gram, then what? If I have a similar calculation, If I take 80 gram calcium, we need 32 gram. Then if I take 1 gram, then 32 divided by 80. Then if I take here 150, then what? Then 32 into 150 divided by 80. Then we can get here 32 into 150 divided by 80. Then 60. For similar result we will found 60 gram. That means, but what we have taken here? We have taken here 80 gram. So if I take just 60 gram amount of oxygen, then 150 gram calcium will be used up. So another 20 gram will be left over. Look, total amount of 80 gram is not used here. If I take 150, then 60 gram is used up, not 80, but we have taken here 80. So 20 gram is left over and calcium is used up. Calcium is run out. So calcium here limiting. This is for this amount. This is limiting reactant. This is limiting. Because for 150 gram we need only 60, but we have taken here 80. At that case the limiting reactant is 150. But if I take here less than 60, suppose 40 or 45 or 45 or 60, any less than 50, less than 60 gram. If I take less than 60 gram oxygen, then this will be limiting reactant, because for 150 gram we need 60 gram, but we haven't take here 60 gram. So oxygen will be limiting reactant. Consider another one, a bigger one. Consider 725 gram calcium and 425 gram oxygen. This amount and this amount. Similarly we need 80 gram to react with oxygen 32 gram. 32 gram will react with 40 gram. Similar calculation. So I can write here. Okay, I am erasing this. This is 80 gram and this is 32 gram. So I am writing here 725 gram, and here we have taken 425 gram. So we know for 80 gram calcium we need 32 gram oxygen. So basing this calculation, this amount, we will find out which one will be limiting reactant. We can write here 80 gram calcium react with 32 gram oxygen. Then 1 gram calcium react with 32 divided by 80 gram. Then I have taken here 725 gram. Then what's the amount? 32 into 725 divided by 80. Then what's the amount we'll get here? 32 into 725 divided by 80. Then we have got 290 gram. We have got here 290 gram oxygen. We have got here this oxygen. Look, we have taken 725 gram calcium and 425 gram, but we have calculated this. If we take 725 gram, it will take only 290 gram, not 425 gram. That means 290 gram will be used up. So look, this is bigger. That means it will be finished up. It will be run out, because for 290 it will react with 290, not 425. If you do this opposite inversely, If I write suppose 32 gram oxygen reacts with 80 gram calcium, then 1 gram react 80 divided by 32 gram, then how much oxygen here? 425 gram reacts with 425 into 80 divided by 32. Then what you'll get here? 425 into 80 divided by 32. Then you have you can get here 1000. You will get, the result will be 1062.5 gram, this amount. If you take 725 gram, it will be limiting reactant. And if you look for 425 gram oxygen, you need 1062.5 gram calcium, but we have taken here only 725 gram. So this is limiting reactant. That means which one will be used up first? Look, if I take 700, if I take here 725, it will be limiting reactant. And if we take 200, this total, if this total amount will be used up, if, then of course there must be 1062.5 gram. Look, for 425 gram oxygen, we need 1062.5 gram calcium. So here we haven't taken this amount. I have taken here this one. So this one will be limiting reactant. That means which one will be used up first? Which one will be consumed, finished up first? This is called limiting reactant. Okay, today up to this. Next day we'll discuss how we'll find out the amount of product you can get from reactant. So today up to this. Thank you very much watching the video.